Good afternoon, everyone. Okay, so what we were doing in the last session? Sound we have discussed. Yeah. We have discussed about Doppler effect. We have seen about reverberations also. Then we have discussed about the use of ultrasounds also. Like where do we use the ultrasounds? What is their property and all? Okay. So we have to start with electricity, I think. We are going to start with this one topic of electricity and magnetism. In the beginning itself, I told you this one part that electricity and magnetism, they are basically the property of electrons. When the electrons are moving, they give rise to what we call as electric current. And when they are oscillating or when they are simply spinning on their own axis, that is what gives rise to another force or another effect called as the magnetic effect. So I think we have discussed about this electric and magnetic in the beginning itself, in the first part, electromagnetic force itself. So now we are going to see certain things like, first of all, we are going to talk about the thunderstorms. Have you read about thunderstorms? So how are the thunderstorms caused? Like we are going to see this one part, not the how cyclones form, how the thunderstorms originate, not in that part. We are going to see this one part of it where we are concerned about the lightning and the sound effect. The electricity in the clouds. We are going to talk about that part. So what is the reason behind it? Like why do we have electricity in the clouds? Why do we have electricity in the clouds? Like if you see that when there is a rainy season, like suppose right now we have the rainy season, so we see that there is lightning in the sky. Whenever there are clouds, when there is a rainy season, there is lightning in the sky. A lightning is followed by a sound also, the thunder sound also. So what is responsible for this lightning and what is responsible for that thunder sound? So this is something which we are going to discuss, that what causes the lightning and what causes the thunder sound which we hear there. So what is responsible for it? To glow light bulb. The lightning is therefore glowing light bulb. What may be the reason why we are having this? Let us try to understand it one by one. This is one part which we have to see as part of the electricity and magnetism. As part of electricity and magnetism, we are going to talk about this. You may have done this experiment many times at your in your school time also, at your home also. You may have done this one part when your hairs are dry and you are combing it, and when you bring it near to a paper, you find that the paper pieces stick to that comb. You can do it with pen also, you can do it with a scale also, or any other thing. Yeah. So whether you are taking a comb or you are taking any such pen, pencil, scale or anything, and if you bring it near to the pieces of paper, it start sticking to that pen or pencil or any object. So the question is, why does it happen? Static charge. We have discussed, we have seen this one thing, that when we are bringing a comb near a piece of paper, so there is an attraction between them. And then after a certain period of time, after a few moments, after a certain period of time, that attraction is gone. That attraction is for a few moments only. The question is, what is the reason behind that attraction and why does it vanishes away? Why does it attract the paper? Or sometimes suppose that if you have switched on your television and you are going near it also, you will find that if you are having some hairs on you, like at least on head you will be having some hair. Yeah. So when you are going near it, you will find that your hair will also be attracted towards that television or towards some electronic devices, displays or other things. Especially if the display is changing also. When the display keep on changing, during that time, you will find that there is attraction. The hairs of your body will get attracted toward that. So again, the question is why? See here. When we are like combing our hair, there is going to be a friction between the hair and the comb. There is going to be this friction between the hair and the comb. And suppose this is our comb. Is it having electron on the top of it? Is it having electron above it? Everywhere you have the electron, from inner part to outer part, everywhere you have electron. So when we are combing the hair, is there a possibility that some electrons might be lost or some might be gained? Some of the electrons, can it come out of the surface? Can it be lost to the environment or can it be lost to other objects? So we see that due to a friction, some electrons may jump out of it or may jump towards it. So let us assume that it has gone out of it. If electrons are being lost by this comb, will it have positive charge or negative charge? It will have positive charge. Why? Normally suppose that this comb is having 100 electrons, 100 protons. Let us assume this. It is having 100 electrons, 100 protons. Now, in general, it is always in a balanced phase. In general, it is balanced. There is neutral charge. The comb is having neutral charge, or most of the objects, they are having neutral charge. So first of all, we see that it is neutral. But when it is losing the electron, then what will be the charge on it? It will be positive charge. Yeah. So this comb is going to become positive. Now if we talk about the piece of paper, it is simply there lying on the ground. So it is going to be neutral. It is going to be neither positive nor negative. Let us say it is neutral. It is neutral. In the middle of it, we have got the proton, and surrounding it, we have got the electrons. So the piece of paper is neutral. The comb is now positively charged. As a result of this positive charge, when we bring it near to the piece of paper, then what will happen that this paper is going to develop a polarity. It is neither going to lose the electron nor going to gain the electron. It will have just a change in its polarity. How that will be done? Positive will get collected on one side, negative will get collected on one side of it. So two poles have been created, on one side positive pole, one side negative pole. So now the paper which is here near this part, it is having negative charge, and the opposite one is having positive charge. So there is no such loss or gain of electron. There is just a polarity which has been introduced. A polarity which has been induced in the case of the piece of paper. So will there be attraction between them two? One is positive because it has lost the electron, and one is negative because there is a change in the polarity. So will there be attraction between them? Okay. So they will get attracted, they will stick towards each other. Now from anywhere, if some electrons are entering into this comb, from the environment, some electrons are entering into this comb. If electrons come back, it will become neutral, positive and negative minus. Okay. If some electrons enter this comb, it is going to become neutral. And in that scenario, will there be attraction between the comb and the piece of paper? So now that attraction is gone, because the attraction was here because this one is having positive charge, the another one was having negative polarity. Due to that, they were attracting each other. But once that positive pole is gone, now that polarity will also be over. That polarity is also gone. So there, the attraction between the piece of paper and the comb will be gone, and they will no longer be sticking to each other. So that is one reason why the combs stick to the piece of paper, or why you go when you go near the any display or any television set or anything, or sometimes like you are having a spark in your blanket also. Okay. So they are all functions of static charge. Static charge is present there, it can cause all these things. Now a same type of a static charge is also there in the cloud. Okay. When we are talking about cloud, how do we see the formation of cloud? How do we get the formation of cloud? What forms the cloud? Dust particles, okay, and water vapor. Okay. So we see that certain amount of water vapor is going up. The water vapor, it is going up. At the same time, some of the water droplets will try to come down also. After condensation, some of the water vapors are going to come down. Water vapor is going up, water droplets are trying to come down. And in the middle of that, there are so many other dust particles also which are present over here. The dust particles which are present in our cloud. So will there be a friction between them? There is water vapor also, dust also. Will there be friction between these particles? They are continuously going up and down, so there is going to be a friction among them. Now, due to friction, can there be generation of charge on them? Okay. So we see that as a result of that friction, let us say that this is a cloud, and here we have got negative charge on this cloud. Let us assume that we have got the negative charge on this cloud. Now this is the Earth's surface. At Earth's surface, we may be having certain houses. We may be having certain plants also. Sorry, it got too big. We have got some plants also. Okay. Plant is, it cannot be bigger than the cloud. I have to reduce this size. Okay. So what we see here, now we have got a plant, and here we have got the cloud. The cloud is having negative charge. Does plant contains atom? Plant is also made up of cells. Cells are made up of atoms. So it means the plant is also consisting of protons, electrons, everything. Now here there is a negative charge. So can there be a polarity on the plant? It is at a height, so there can be development of a polarity on this plant. It can be having this positive charge. So here we have got now a negative charge and a positive charge. There is going to be like a connection between them, an interaction between them. There is going to be a force of attraction between them. Here we have excess charge, here we have excess electron. Here we see that a polarity, a opposite polarity is formed. So as a result of this, this charge is trying to come down here. This charge will try to go towards the positive. Now, if there is cloud, and suppose there is rainfall, there is one condition when the air is dry. First condition is when the air is dry. Can dry air conduct electricity? Dry air, can it conduct electricity? It cannot conduct electricity. It is a poor conductor. Dry air cannot conduct electricity. But if there is a moisture in the air, the moisture in the air can make the air a conductor of electricity. If there is a moisture there, and how will moisture come? If there is rainfall, there is going to be moisture. Tell me one more thing. Distilled water or ultimate pure water, is it a conductor of electricity? Distilled water. So distilled water is not a conductor of electricity. If water is very pure, ultimately pure, then it is not a conductor of electricity. If water is having some impurities, then only it can conduct electricity. Now, rainwater, is it pure or impure? Impure? Yeah. Rainwater is having so many impurities. It is having impurities like salt, dust particles, acid, many things. So, rainwater is not pure, rainwater is impure. It is having several, it is impure, simply it is impure. It is having acids also, it is having dust particles also, various salts also. So now it is a water which can conduct electricity. So here we have the, like, now we have got a conducting medium. Now we have got here negative charge, here we have got positive charge. So can electricity pass through this medium? Can electricity pass through this medium now? Okay. So electricity will now be flowing from the cloud towards the plant, from negative charge to positive charge. Electricity flows from negative to positive charge. Now see here, if it is flowing from negative to positive charge, we see that there is a light in the sky. When there is a lightning, we see a very very bright light in the sky. So why do we see that? This is the flow of electricity. So why do we see the light? Now remember this one part, in one of the class we were talking about the LEDs, and there I told you that if electron change their state, if the electrons change their orbit, they are going to release energy in the form of light. Like here, if you are having the light from LED, it is just because they are changing their orbit. They are changing their state of orbit. And when they change their state of orbit, they are going to release energy. That energy comes to us in form of light. So when here we see that there is electricity. Electricity is what? Electricity is the flow of current. Means flow of electrons. Sorry, electricity is the flow of electrons. So when electron is moving, it is changing its orbit. It is going to release energy. That energy appears to us in the form of light. Like you see the LED, in same manner you see the lightning also. So lightning is just because of change in the energy state of the electrons. That is first part. But we hear a sound also. So why do we hear the sound? Yes. The sound is because of the vibration of the air particles. The sound is because of vibration of air particles. Sound is always generated due to vibration. We have seen it last day also. So when this huge amount of energy is passing through it, when the huge amount of energy is passing through the air particles become so much heated that they start to vibrate. And the vibration of the air particles here is resulting into the thunder sound which we hear. So we hear the thunder sound later than the light. There are two reasons. First, sound is not created first, sound is created later. Okay. And second thing is speed of sound. Speed of sound is 340 meter per second. The speed of light is 3 lakh kilometer per second. So there is no comparison. But even if they were comparable, we would have still then seen the light first. Because light is first passing through that area. That light is the region why the particles are vibrating. They are the region behind the vibration, and the vibration causes the sound. The sound is not only reaching us later, it is also created later. So that's why in the case of the monsoon season or in case of clouds, we see the lightning and we also hear the thunder sound. So write a little bit about this. First, give the heading electricity and magnetism. Give the subheading electricity in the clouds. COM thing I am not going to dictate. If you ever have difficulty in finding why there is electricity in COM, try at your own home. Okay. You can do the experiment and then you can find out. So, may have seen that when we talk about the electricity in the cloud, it was proved through a kite. Like the electricity which is existing in the cloud, how do we get to know that? There was a experiment which was conducted by who conducted this experiment that there is this electricity in the cloud. There is very popular stories also in like NCRTs and everything. So there was a person who was having a kite. He was flying it in the sky during the time of monsoon. Okay. So what was the name? What was the name of the person? Benjamin Franklin. Okay. So you have forgotten everything, right? Someone is saying Kuldeep. You're taking your name. I thought you were writing about Kuldeep Yadav from Indian team. Okay. Benjamin Franklin. Okay. So he has conducted a test like where he has flown the kite. So whenever you have any difficulty in understanding electricity or the electricity in the cloud, take a kite. This is the time of August also. In August in Delhi, you will find too many kites due to Independence Day and all. You'll find kites are there all over the city. Try to take one of them. This is the right time also. You can start flying the kite in the morning. By afternoon, you will discover electricity. Okay. So there may be a challenge that the amount of electricity which you receive, it is going to be enormously high. The electricity which comes in one strike, one lightning strike, is sufficient to run the or to meet the electricity demand for 1 year for a particular city. If we are talking about one city, one such thunder strike is having sufficient energy that it can run all the appliances for 1 year. So free electricity. Yeah. Tell right about this. Electricity in the cloud. When clouds form, when clouds are getting formed, when clouds are formed, are getting formed, then during that time, during that time, water vapor is rising up. Then during that time, water vapor is rising up. Water droplets are coming down. Water vapor is rising up. Water droplets are coming down, as well as there is random motion of dust particles, as well as there is random motion of dust particles. It leads to friction among the particles. It leads to friction among the particles. Friction among the particles, which results in formation of charge over the cloud. Formation of charge over the cloud. Charge over the cloud. If a cloud is charged, if a cloud is charged, it will also induce, if a cloud is charged, it will also induce polarity. It will also induce polarity on any object, on any object of taller height, any object of taller height on the ground. Next point. Due to presence of moisture, due to presence of moisture, the air starts acting as, the air starts acting as a conducting medium. The air starts acting as a conducting medium. It leads to conduction of electricity. It leads to conduction of electricity between cloud and the object on earth. Between cloud and object on earth. Between cloud and object on earth. In this process, electrons, in this process, electrons are shifting or changing electrons are shifting or changing their orbit or energy state, their orbit or energy state. Due to shift in energy state, due to shift in energy state, there is release of energy. There is release of energy in form of light. There is release of energy in form of light. In form of light. Which we see as lightning in the sky. Which we see as lightning in the sky. When this enormous amount of energy, when this enormous amount of energy, when this enormous amount of energy is passing through the air, the air particles gets heated up. The air particle gets heated up. The air particle gets heated up. As a result of this, they start vibrating at very high speed and results in thunder sound along with lightning, and results in thunder sound along with lightning. So this is first part, what is lightning, what is this lightning as well as the thunder sound in the sky. Okay. In disaster management, you will have to read it as a particular disaster also. Okay. When you will read disaster management section, there you will find that lightning is causing many deaths in several parts of India, especially in some of the eastern states, parts of Meghalaya and other regions. Okay. These are the areas where we have intense lightning activities. It has been acting as a disaster, causing more death than many other disasters. So lightning is a very prominent challenge in especially the eastern states or the northeastern states, where we have mixing of air, very high, you can say that very high intensity winds are colliding over there, and it is causing intense lightning. So that is very much common in parts of Odisha, West Bengal, Bihar, and other regions. Even in parts of Meghalaya, some portions of Mizoram, and little bit part of Assam also. These are the areas where we have intense lightning activities. Now, coming forward, we are going to see this one part, along with it, the magnetism section. We will come to their application, combined application, but first we will see this magnetism. I have explained it to you earlier also, that magnetism is not basically a new force. Magnetism is an electric force only, but it is an electric force in a perpendicular direction. When there is the spin of electrons on its own axis, it gives rise to magnetism. So magnetic field or magnetic force is basically an electric force only, but it is there in a perpendicular direction. Okay. So that is one thing which we know about the origin of magnetism. But when the electron is oscillating or it is spinning on its axis, their combined effect gives rise to magnetism. I think I have dictated it also earlier, that what causes magnetism and all. Now, in this part, we have to understand one very critical thing. Earth is also having its magnetism. Why would Earth have magnetism? Why is Earth having magnetism? Abhishek, you will read that in disaster management part. You have to read that. Here we are talking from the science perspective. We are not talking from the disaster management perspective in this part. In disaster management, you will read that separately. Okay. So why we are having this magnetism in case of Earth? Iron and nickel, they are present in the core of the Earth. Okay. Anything else? Like? So what dynamic change that is it is bringing? See, iron and nickel is region, and the nature of core is also the region. The thing here is that first of all, we have not only us, all the other planets, many of the stars, they are also having magnetic field. It is not something unique for the Earth. Many of the planets are having far bigger, far stronger magnetic field than what Earth is having. It is because of presence of iron or nickel in the iron and nickel in the core of the Earth. Plus, at the same time, we also see this one thing, that the inner, when we are looking at the outer core, it is liquid. The inner core is solid. The outer core is not only liquid, it is also continuously moving. So think about this. You have got all the atoms which are also moving, and that too atoms which are made up of the atoms which are just atoms of iron and nickel. They are also moving in a circular manner. So they are going to create a magnetic field which is not only static, it is dynamic, it is changing continuously. Okay. So Earth is having a dynamic magnetic field, a magnetic field which is continuously changing. The source of the magnetic field is basically the presence of iron, the presence of iron and nickel in the core and the rotation of it. The materials are also rotating inside. They are giving rise to this magnetic field. Okay. Now, when we talk about our Earth, we have seen that it is having the magnetic field. That's fine. Okay. So every magnet is having one thing like North Pole and South Pole, which we have created. Magnets are not having North Pole or South Pole. We have named it. One is North Pole, one is South Pole. So in the beginning, what did we do? Like the part of magnet which was pointing towards the north, we called it as North Pole. And the one part which was pointing towards the south, we called it as South Pole. So in the beginning, when we were naming the magnets, so we called it as North and South Pole. At that time, we were not even aware about this thing, that Earth is also having a magnetic field, or Earth is also acting as a magnet. At that point of time, we didn't have knowledge about it. So the bar magnet which was pointing towards north, it was simply called as North Pole of the magnet, and then the one towards the south was called as South Pole. Again, later on, when we started understanding this one part, that Earth is also acting as a magnet, we again called this one thing that this is the north magnetic pole, this is the south magnetic pole of the Earth. Okay. We called this side as north magnetic pole, and we called the opposite side as south magnetic pole. Now there is one challenge. We know that north will attract south and north will repel north. So now think about this. If we are putting a bar magnet, if it is having North Pole here, we are seeing that this north is getting attracted to the North Pole of Earth. So how would that take place? We are seeing that the North Pole of the bar magnet is pointing towards the north magnetic pole of the Earth. So how this can happen? Normally we know that North Pole attracts South Pole, North Pole will repel North Pole. Opposite poles attract each other, same poles repel each other. That is the basic formula in case of charge also, in case of magnetic field also. So now the question is, why we are seeing this one thing, that the north magnetic field of Earth is attracting the north pole of bar magnet. So what is the reason? The reason is very, very simple. We did a mistake. Okay. It is as simple as that. We did a mistake. We named both of them as North Pole. And later on, we didn't change it because all our appliances are based on it. Okay. So we didn't change it. We allowed the nomenclature to go like that. Okay. We allowed the nomenclature to go in the same manner. Like suppose that when you are looking at a battery, if there is a positive side of battery and negative side of the battery, okay, this is the positive pole of the battery and this is the negative pole of the battery. Okay. So what is the actual motion? The actual motion of current is the motion of electrons. Current is not the motion of protons. But how do we denote it? How we denote it from positive to negative? We always decide that like the charge is moving from positive to negative. But in fact, it flows from negative to positive. But we could not change it because initially we have based all our equipment on this simple connotation, that charge always moves from positive to negative. In same manner, when we did this one part here, that the north pole and north pole of earth is also in this direction, and north pole of the bar magnet is also directing toward this. We didn't like change it initially, and later on we didn't get the chance. But in later we cannot change it also. So right now we are like having the same confusion in case of this magnetic field. The north pole, the north magnetic pole of earth is also in the north direction, and the bar magnet also points towards the north direction. Either one of them is south. Okay. Either the bar magnet is south or the earth's pole is south. But it doesn't matter. Okay. It doesn't matter, because in nature there is no concept of north pole or south pole. In nature there is only one thing, that there are two different poles. Okay. So it is not about north pole or south pole, it can be anything. It doesn't matter at all. That's why we don't like go in the detail of it, like why we have named it, why we have not changed it. In nature we know that there are two poles. You call them north, south, east, west, it doesn't matter. Suppose tomorrow Trump decides that no, north will not be called as north, north we call as Trump, south will be called as Donald. Okay. So then he will have to change the entire connotation, and he can do anything. Okay. So if tomorrow he decides this, that north will not be called as north, so then what you can do? Nothing. Okay. So this is the part with case of this magnetic field. Okay. So earth is also having a magnetic field. Now when we will read the universe part, we will come back to this section again. Remember this one part, we will come back to this part again, because we have to see one thing with respect to it, and that is geomagnetic storm. Okay. So earth is having a magnetic field, and this magnetic field is protecting or shielding the earth from the harmful rays, harmful like plasma coming from the sun, harmful solar waves coming from the sun. So we have a utility of this magnetic field, but we will see that later. Once we have studied sun and everything, then we will come to that part. Okay. So for the time being, remember this one thing, that earth is having a magnetic field. What will be its use? We will see that later. Write this one part. I'm not going to dictate again about magnetism. I'm going to start with this one part. Magnetic property of earth, or magnetism in earth. Magnetism in earth. Write down. Earth consists of iron and nickel. Earth consists of iron and nickel. Iron and nickel in its core. At the same time, in the outer core, iron and nickel are in circular motion. Iron and nickel are in circular motion continuously. This gives rise to a strong magnetic field around the earth. Strong magnetic field around the earth. This magnetic field is considered as dynamic. This magnetic field is considered as dynamic as it continuously changes as it continuously changes according to location and time. According to location and time. I think you have drawn that north magnetic and south magnetic pole. Yeah. Now, one thing more here. When we are talking about the magnetic field of Earth, right now what we see that, like when we are looking at the Earth, let's say when we are talking about Earth, this is the geographic north and geographic south. The geographic north and geographic south. What we see that the magnetic north and south are slightly away from here. North magnetic, south magnetic. Okay. So there is a difference of near about 11 degree. There is a difference of near about 11 degree between geographic north and magnetic north. Now the question is why? The simple thing is this changes continuously. The magnetic field of Earth is not constant. It is continuously changing. The one which is north today, it is going to become south after 3 or 4 lakh years. Yeah. So if it is north right now, after 3 to 4 lakh years, it is going to become south. And the one which is south will become north. Because it keeps on changing. After some period of time, it will come here. Then it will come here. Then it will come here. So it will keep on changing. After every 3 lakh years, the north becomes south, the south becomes north. Because the material which is inside the Earth is continuously moving, but its speed changes, its direction reverses. The core particles, the particles inside the core, it is having varying speed. Sometimes its direction also reverses. So there is a change in direction of the material of the core. And when the direction of the material of the core, the speed and the direction, when it will change, it will also impact the magnetic field. So Earth's magnetic field is in fact not a constant thing. It is continuously changing with respect to time. That is one thing which we have to understand here, that it is something which is continuously changing as per the time conditions. Yeah. So write down this one part also. The magnetic field of Earth, the magnetic field of Earth is continuously changing. The magnetic field of Earth is continuously changing. It reverses its polarity. It reverses its polarity every 3 to 4 lakh years. Every 3 to 4 lakh years. It is because of the variation in the speed and direction. It is because of variation in the speed and direction of the particles inside the core. Okay. So this is one part, this is one part about the variation in the magnetic field. It continuously changes. Now, like when we are talking about the use of electric and magnetic field, there is one part. You might have read this in class 10th that electricity is used to run motors. or generators are also used to run, or generators are used to generate electricity. So there is a like use of electricity to create magnetism, or use of magnetism to induce electricity. So they are always used to generate each other or to induce each other. Like in the electric motor, when we are having the electric field, that electric field can cause the motion of the object by changing that magnetic and all axles. It will change the magnetic axles and it will lead to moving of the motor. Whereas when we are moving the motor, when we are moving that magnetic field in a generator, that leads to also generation of electricity. Have you read that in class 10th or not? Electric motor and all. Generator, electric motor. Yeah. What other things can be there? What other uses can be there when we are talking about this electricity, when we are talking about this magnetism? What other possible uses are there in case of this electricity and magnetism? Like, why do we use the electricity? Usage. Do we make switch appliances on the basis of electricity? That is a basic part. There is one thing called as heating effect of electricity. Now, where do we use the heating effect? Heater. That is as simple as that. When you have the heater, there you are converting the electricity in form of heat, in form of heat energy. At the same time, we are also using it to generate now like light also. We are just using the electricity, we are passing it through a semiconductor diode, and that is also giving us light. We are also using the heating effect for switch purposes also. Like, how does the switch work? What is the work of switch? Sorry, not switch, fuse. Sorry. What is the work of fuse? How does it work, fuse? Say, if UPSC asks you a simple question like this, that how does a fuse work? And if you are not able to answer that without reading science, then it will be a crime. Okay. You don't even have to read science for it. To maintain the current voltage, what is the working principle of a fuse? In class 9th, class 10th, you have to read this. How does the fuse work? Resistance. How does that resistance work? Yes. It is as simple as that. See, there is an appliance. Let us say we have connected an appliance which is taking a power of to, like, let's say 10 watt, or it can withhold 10 ampere. Okay. We are using a battery and we have added a fuse over here. Let's say we have added a fuse over here. This fuse is having capacity slightly less than maximum capacity of the appliance. If the maximum capacity of the appliance is 10 ampere, the fuse will be of, let's say, 8 ampere or 9 ampere. If more than that current is passing through it, the fuse will melt. So it is simply on the heating effect, that due to the excess heat produced by the electricity, it is going to melt down, and then it is going to disrupt the entire electric circuit, and then current will not flow. Okay. So fuse work on this principle. Okay. Then you have heater working on this principle, motor and other things working on this principle. Okay. Electricity is also used for one thing called as electroplating. Electroplating, like suppose we have one such spoon made up of copper, you have to give it to someone. but you want to say to them that it is made up of gold, there is one simple option. You can do the electroplating of gold, like on that copper also. So what you can simply do, you can take a solution of gold sulfate or any such salt of gold. Yeah. Then you can pass the electricity through it. When you are passing the electricity through it, when you are like allowing the electricity to pass through that solution, then what you will find that the the amount of gold which is there in the solution, it is going to be deposited on that substance which you want to be plated. So that is one thing which we see in case of this electroplating. Electroplating is one thing which can be done easily with the help of electricity. That is called as simply the chemical effect of electric current. So these are some basic things. Like if you want to write them, you can write them, or otherwise it's not necessary. Write one simple pointers. Yeah. Uses of electricity. First, heating effect. Heating effect of electric current. Heating effect of electric current. When electricity, when electricity is passing through a material, some amount of energy, some amount of energy is released. Some amount of energy is released in the form of heat, released in the form of heat because of resistance. Because of resistance. For example, for example, when electricity passes through appliance or wire, it becomes heated. Just give me 2 minutes, I will be back. So we have written about heating effect, right? Okay. Next, write this one thing. When electricity, second point is chemical effect. Second part is chemical effect. Here we have written about heating effect, that wire gets heated. Okay. Write about chemical effect. When electricity passes through a solution, when electricity passes through a solution, it can break it down. It can break it down into its components. This chemical property or effect, this chemical effect is instrumental, is instrumental in electroplating, in electroplating, as well as electrolysis, as well as electrolysis of water. Electroplating as well as electrolysis of water. In the present time, electrolysis is more famous than electroplating, because electroplating is traditional thing. It has been done for a long period of time. Electrolysis of water, to perform this or to produce this hydrogen gas, is the new thing. In the case of electrolysis of water, we are producing hydrogen gas. Yeah. So that is one thing which we are doing here in case of electrolysis. So that is chemical effect. Yeah. At the same time, write next part, magnetic effect. Electricity can induce, electricity can induce magnetism. Electricity can induce magnetism in a substance and vice versa. And vice versa. Means magnetism can also induce. Electricity can induce magnetism in a substance and vice versa. So that is the magnetic effect of electric current. It can induce magnetism also. For example, creation of electromagnets. For example, creation of electromagnets. Now there is one thing called as conductor, one is called as insulator, and another thing is called as semiconductor. So I guess you know about them, conductor, insulator and semiconductor. So this wood, it is insulator or conductor? Pen? You don't know what it is made up of. Yeah. It may be made up of steel also, or iron also, or copper also. But upper coating is of course plastic. Yeah. So conductors are those which are able to conduct electricity easily. Insulators are those which are not able to conduct electricity properly. Semiconductors come in the middle. They are those substances which can conduct electricity in certain cases or cannot even conduct electricity in normal cases. Yeah. So in general, they don't conduct electricity, but with the addition of impurities, they are able to conduct electricity. Semiconductors are more valuable in the present times as compared to conductors. Yeah. Because conductors have only one thing, they will be conducting electricity. Semiconductors are the one which can conduct electricity of various proportion as per our requirement. They can either conduct more electricity, less electricity, no electricity, or full. Okay. So semiconductors are the one which we can modify, which we can change. So that is one of the most important substance in the present times. All our electronics items and other things, they are coming from semiconductors. So write a little bit about them. In general, one line each. Can conduct electricity easily. Can conduct electricity easily. Difficult to conduct electricity through it. difficult to conduct electricity. In semiconductor, you can write, generally they are insulators. Generally, they are insulators. Generally, they are insulators, but on addition of impurities, but on addition of impurities, on addition of impurities, it can start conducting electricity as per requirement. Now we are starting the third most important segment from general science, from where questions will come in the examinations in the present time. One part was cell, another part was human body and diseases, and third part is this one, universe. This is one part from where question comes in the examination. Rest all others are just a part of syllabus, but it is not so important for exam. This is one part which is going to be very crucial for your examination. Okay. So here we are going to see all the things in detail, and we will try to understand what type of questions will also be coming. Because till now, in the last 15 years, you will find questions have been there from cell, microorganisms, human body and diseases. A few questions have been there about forces. But apart from this, no questions from electricity, no questions from magnetism, no questions from, one time in 2013, question was from light, the dispersion and rainbow formation. But after that, questions have not been coming from these sections. But there is one part in which you will find that per year, there is one or two questions. In 2023 also, there were 2-3 questions from universe section. In 22 also. In 24, they have again focused back on virus and human body and other cell part. Yeah. So now we are going to see this one thing, like universe. Superconductor, we will come to that when we will see the Bose-Einstein condensate. When we will see the Bose-Einstein condensate, then we will come to this one part, what is superconductor. Okay. So don't worry about it. Superconductors we have to see. Okay. So there is one thing called as universe. So what do you know about universe? What is there in universe? What is universe made up of? What is the extent of universe? How universe started? Where universe is going? What are the parts of universe? There is one section on which there might be a question in mains this year, and that is about dark matter and energy. In the last 1 year, there have been so many experiments just focused on this. We have been observing the galaxies, we have been observing the distant planets and all for this one purpose, that we have to know about the dark matter. Yeah. So dark matter is a part of universe on which you can expect a question in mains, or if not mains, then next year prelims. Yeah. So this is one part. We will try to understand what is universe. Yeah. In Sanskrit, there is a slok which says that Yatha Pinde Tathe Brahmande, Yatha Brahmande Tathe Pinde. Yeah. Which means whatever is inside our body is there in the universe, and whatever is there in the universe is inside our body. Yeah. So that is one such thing which tells about the universe and the relation of human beings. That whatever is inside our body is also in the universe, and whatever is there in universe is inside the body also. Okay. If you want to see the relation, when you see the DNA structure, it is resembling to the structure of nebula. Okay. When you see many such part of the human body, you will find its resemblance in the universe. The structure of human body has many resemblances in the universe, from DNA structures to the skeletal system to other systems. They have resemblance to the structure of universe. And in general also, you know that whatever substances are there inside our body, there is also there in the universe. And substances which are there in universe, the different types of atoms and all, they are also present inside our body. So in general also you can see that part. Plus energy. Okay, the one factor, energy. You know that there are various energies which are present in the universe, and various sources of energy or various energy inside our body also. So that's why it is said that there are so many things which resemble between human body and universe. Yeah. There is one way of seeing this one thing, that there is no existence of earth in the universe. In the vast universe, there is no existence of earth. But at the same time, if you look from the other way, it is one such area which is different from all other parts of universe also. That this is one part which we know about, where we are thinking about the universe, that what universe is made up of, or what is the size, what is the different dimensions of it. So there is one way of looking at it, that earth has no existence. While if we look from the size, earth is very small. But if we look from the intellect which is there, it is again enormous. We know a lot of things about universe. We have been talking about how it all began, what are the various sources of energy, what are the various matters, what is the different dimensions. So if you look from the size part, it is very small. But if you look from the intellect, the awareness among the people, then it is significant. Then it is quite special. It may not be the only one, but it is one of the special one. Okay. So that is like one perspective of earth in the universe. Either it is nothing or it is something very good. Okay. So we will talk about this universe. It is believed that initially there was nothing and it was nowhere. There was no existence of a space, there was no existence of time. There was not a place where universe was there in the past. There was nothing. And from that nothingness, from that zero, there was one massive explosion. And that explosion took place near about 13.6 billion years ago. There was nothing, and then there was a huge explosion 13.6 billion years ago. That explosion created huge amount of energy. Okay. That explosion resulted in release of huge amount of energy. This led to release of huge amount of energy. Now when this energy released, initially for some time there was no matter. There was no matter initially for some time. Later on, some subatomic particles started to form, not the electrons, proton. For some lakh years, for some of the lakhs years, there was no electron, no proton, nothing. Later on, we see that there was formation of electrons, protons, neutrons, and the first atom in the form of hydrogen. Okay. So initially, the energy came first. Energy got converted in the form of matter. So matter and energy were not created simultaneously. First, there was release of energy, and then there was release of matter. So first there was energy, later on it was followed by matter. Now there is one more part. When universe was formed, it started to expand. Now the question again starts, where it is expanding, where it is located that it is expanding, in what part the universe is present where it is expanding. The answer is there is nothing, but it is expanding. The universe is expanding by itself. There is no area in which it is filling. It is simply expanding. It is simply getting stretched. It is simply like creating its own realms. Universe is creating its all realms. It is also creating the space. It is creating the time. So each and everything starts with the universe. These things start with the universe. There was nothing there, but then it started to evolve. Yeah. So what we see that this is expanding. This is expanding. When initially the universe was created, or sorry, universe originated, not created, when the universe originated, at that time it is believed that it was expanding at an unimaginable rate. We are not even able to predict that what might be the rate of expansion of the universe in the beginning. In the present times also it is expanding, but now it is believed that there is different rate at different locations, and at some point of time it may appear that it is like expanding more than the speed of light, and at other places it may seem that it is not expanding at all. Like if you try to see the distance between earth and sun, you will find that there is no expansion. But when you see the difference between the galaxies, you will find that there is enormous expansion. So it depends on our like reference point. If we see within it, so we see that there is no expansion. But when we look at the broader universe, then we see that there is enormous expansion. So this universe is expanding. That has been like observed many a times. The first thing is this part, that it got started 13.6 billion. Now there is one question, that what are the different components of it? What are the different parts of this? What are the different components of it? So there is one thing, there is one component called as matter. There is another component called as energy. So what is matter? Matter is anything which has some mass, occupies some volume. Okay. So that is basically matter. Okay. Matter is each and everything, the air which is around us, the human body, the planets, the stars, all these things are matter. There are certain substances which are having there some mass, they're occupying some volume. So they are basically our matter. And then we have another thing called as energy. Okay. Like we have the light energy, we have the sound energy, the tidal energy, wave energy, geothermal energy, nuclear energy, strong, like all these things, they are part of the energy part. But is it the entire universe? This matter and energy, even if we combine them together, they combinedly account for only 5% of universe. Combined together, they are just 5% of universe. Like when we are looking at this part of energy and matter, let me tell you one simple thing. Suppose when we are talking about our galaxy, Milky Way galaxy, in that Milky Way galaxy itself, recently some of the scientists who have been part of James Webb Space Telescope, they have said that there are around 400 billion stars in case of Milky Way galaxy. 400 billion stars. From there you can like imagine how many planets will be there, how many asteroids, how many comets, and how many other substances will be there. So there are 400 billion stars in our Milky Way galaxy. And when we compare the universe, when we see the universe, there is not one or two or hundreds of galaxies. There are billions of galaxies in the universe. So each and every galaxy consisting of billions and billions of stars. So you can imagine from that, if we are having like several trillions and trillions of stars in the entire universe. And these stars, if we want to compare them, what is their size, what is their mass? Just see this one thing. Sun is one of the smallest star. We have seen there are trillions of stars in universe. If we look at this, Sun is a very small star. And within the solar system, we have planets like Jupiter, Saturn, Uranus, Earth, 8 planets, okay, plus all other small planets, dwarf planets, all the asteroids, all the comets. If we combine them all together, they form just less than 1% of Sun. All the planets and each and everything in solar system account for less than 1% of Sun. From this you can imagine that what is the size of the Sun, what is the mass of the Sun. And just now see this one part, that within just Milky Way galaxy, we are having 400 billion Sun-like star. Many of the stars are even much more bigger than what we call Sun. And then there are like billions and billions of galaxies like this. So if you see the entire universe, you can imagine how much matter may be there in this universe. And all this matter combined together, it is less than, plus all the energy which is there. Means they have got the light energy, all the energy which is there. So all these energies combined together are not even forming 5% of the universe. Yeah. So this is like the size of the universe. They are just 5%. The question arises here that what is there in the universe then? What else is there in the case of universe? There is one thing called as dark matter. Now the question is why we said that there is dark matter. Like suppose that we are having a star over here. And we are also having a telescope over here. The rays from this star is going in this direction. But we see that it has bended from here and came to this telescope. It has bended here and it has come to this telescope. This is what we call as gravitational lensing. We have discussed that in our fourth section, that when the light is bending, it is called as gravitational lensing. Why do we have gravitational lensing? We have seen it previously that if there is a very powerful star, if there is a black hole or neutron star, then there is a chance of gravitational lensing. Let's suppose if there was presence of any such black hole, or if there was presence of a neutron star, or any such like powerful star, and if there was a bending, we can understand it, that they may have caused this bending of light. But when we observe here, we see that there is a bending of light, but there is neither a black hole, nor a neutron star, nor anything heavy in this area. When we observe here, and if we find that there is nothing, not even a star, not even a black hole, not even any such object, and still light is bending. So why will the light bend? Light bends because of gravity. Light is bending because of gravity. But there is no source of gravity. There is nothing present in this area which can cause gravity. If there was presence of black hole or anything, then we could have understood that it may have been caused because of it. But we see here there is neither black hole, nor neutron star, nor powerful star. So why does it bend? So then scientists came to this conclusion that there may be presence of certain matter over here. There may be presence of certain matter over here which is not visible to us, but it is having enormous mass and gravity. There is an object here, there is something object here which is having very intense mass, very high mass and gravity. But we are not able to see it. We are not able to detect it. But there is presence of gravity which we can feel. We are feeling the gravity, but we are not feeling the mass. We are not seeing the mass. We are not able to detect the mass. So this particular thing was called as dark matter. This was called as dark matter. But this was not the only evidence. This was not the only evidence. In various parts of the universe, we know that the stars are basically moving around the black hole. Like when you see the sun is also moving around a black hole. There will be a time in the universe when sun will go inside the black hole. Okay. You don't have to worry about it. Right now we don't have the situation. Okay. So there will be a time when sun will be merging with a black hole. It will be many, many billions of years later, but it will take place eventually. So every star is generally following a path around a black hole. But we have been able to see this, that there are certain stars which are moving around an object which is not a black hole, which is not even a neutron star or not even a dense object, but they are just orbiting around it. So why would a star orbit around vacuum? Why the star is able to experience gravity in vacuum? Nowadays we are able to detect black hole. We know the characteristics of black hole much more than what we knew 60 or 70 years ago. But there are certain parts of the universe where there is no such black hole, where there is no such presence of black hole, and still the stars are orbiting around that area. Or the gravitation which is experienced around there, it is enormously high. So on the basis of that, we concluded this part that there are certain objects which are not visible to us. There are certain things which are not in our capacity of detection. We are not able to detect them. So we have called them simply as dark matter. We have simply called them as dark matter. So now, see, there have been a few times question about this also in the past. If someone asks you, what is the property of dark matter? Can you tell me what will be its property? Is it positive charge? Is it negative charge? Is it neutral? What is the property? What is the property of this dark matter? Is it positive, negative, neutral? What substance it is? The simple thing is, we don't know. That's why it is called as dark matter. It has been named as dark matter because we have not been able to detect it. If we would have been able to detect it, we would have named it after someone. Yeah. So like Donald matter, it could have been changed into Donald matter or anything else. But right now it is called as dark matter. It simply means no property detected yet. So that is one simple thing. Officially, there is no property of dark matter which has been detected yet. Because we have not been able to see them. We have not been able to locate them. We have no instrument which can detect them or analyze them. We only know that they are existing. We are trying to find them. We are trying to find them through our telescopes. We are trying to find them through our LIGO observatory, through James Webb Space Telescope, through various other telescopes. We are trying to find them. But the fact remains the same. There is no property of dark matter which has been detected till date. There is only like projections that this may be having this type of property or other type of property. But officially, there is no property of dark matter detected yet. Now, so this dark matter, it has been considered 20 it has been considered to be part of 27% of the universe. It has been said that it is 27% of the universe. Matter and energy combined together is 5%. The ordinary matter and the energy combined together is 5%. But this dark matter, it is it has been calculated that the entire gravity and everything which is there in the universe, on the basis of that, we have calculated it that it may be something around 27%. So if you add them together, okay, if you add them together, it forms like 32%. So still we have 68% remaining. Now just think about this. When you see the black holes, when you see all the stars, all the galaxies, everything, trillions of stars, millions of dark black holes, millions and millions of black holes, trillions of stars, all combined together 5%. Plus, we see that this is also like 27%. So there is so much mass, there is so much like gravitation in the universe. There is so much gravitation in the universe. So why the universe is expanding? Universe should have collapsed into a ball. It may have collapsed into a tiny point. There is enormous mass in the universe. So what motivates the universe? What is giving that motivation to the universe? That it has to keep on expanding. So there might be some energy which is responsible for this infinite expansion of the universe. Universe is simply infinite. It is beyond our imagination. Like generally we say that we can imagine anything. So try to imagine what will be the extent of universe. Try to imagine what will be the extent of universe. You cannot even guess what will be the extent of universe. Okay. So when we look at the universe, it is infinite. Our thinking process is a part of it. We cannot go beyond it. It is quite difficult to go beyond it. Okay. Now, in the same case, so what is responsible for its expansion? What energy is there? Is it light energy, nuclear energy, fusion energy, fission energy? What is responsible for this? Fission, fusion, light, sound, tidal, each and everything, they are part of 5%. Each and every energy which you know, all the nuclear bombs combined together in all the planets across the universe, they are still just 5%. Okay. So it's not about just the earth and a few countries. All the energy combined together of the entire universe, which we know about, they are just 5%. So what causes this expansion? So this expansion is something which is caused by one thing called as dark energy. And this is considered to be 68% of the universe. Okay. So dark energy is considered to be energy responsible behind the expansion of the universe. We don't know again that what is the property of this energy. We don't know the source of this energy. We don't know how it transforms or what it causes, but it exists. Yeah. It is existing, it is causing the expansion of the universe. Otherwise, there is no reason why the universe will expand. Universe has so much mass that it can collapse within a tiny second, not even second. Like in black hole, time is gone. So think about this. One galaxy is having thousands of black holes. One single galaxy may have thousands and thousands of black holes. And there are billions of galaxies in the universe. So from there you can imagine how many black holes are there. So, and at the same time, these all mass would have led to the collapse of the universe. This entire dark matter and ordinary matter, they could have collapsed the entire universe, but it is not collapsing. The one which protects the universe from collapsing, the one which causes its expansion, that energy is what we call as dark energy. It has again No such property which is detected by us. We don't know about it. We simply know that there is an energy which exists, which causes the expansion, or which might be responsible for the expansion of the universe. We don't know the source, we don't know its type, we don't know where it has come from, where it is going, what is its nature, but it is there. We know only that part, that some energy is there, and that energy has been called as dark energy. It's not that dark energy is dark. We are unaware about it, hence we have called it as dark matter and dark energy. Okay. It is not Kala Jadu. Okay. So write about this first, about the universe. The universe originated. The universe originated near about 13.6 billion years ago. The universe originated near about 13.6 billion years ago. In the at the beginning of the universe, at the beginning of universe, there was a release of infinite amount of energy which led to expansion, which led to expansion, which led to expansion of the universe, which led to expansion of the universe at unimaginable rates, at unimaginable rates in the beginning. The universe, the universe consists of consists of ordinary matter, ordinary matter, energy, dark matter, and dark energy. The ordinary matter, the ordinary matter forms the ordinary matter and energy. The ordinary matter and energy forms only 5% of the universe. Forms only 5% of the universe. Whereas dark matter and dark energy are 27% and 68% respectively. Whereas dark matter and dark energy are 27% and 68% respectively. Now we will write about this dark matter, that why we came to this one thing, that why we are saying that there is dark matter. Yeah. So we will write this one heading, dark matter. In that, write this. In our universe, in our universe, researchers have been able to observe in our universe, researchers have been able to observe Gravitational lensing. Researchers have been able to observe gravitational lensing of light in areas, gravitational lensing of light in areas where there is no presence of black holes, neutron stars, or other known celestial objects, or other known celestial objects. Other known celestial objects. Celestial means everything is which is there in celestial. Yeah. Other known celestial. Known part is very important. Other known celestial objects. Yeah. Have been able to observe gravitational lensing in even those areas where there is no such known celestial object. It led to a hypothesis. It led to a hypothesis that there may be presence of certain matter in the area. There may be presence of certain matter in that area which is causing gravitational lensing, by its enormous gravity. However, any property of this matter has not been detected. However, any property of this matter has not been detected till date. Till date. Due to this, scientists call it as dark matter. Scientists call it as dark matter. Other part, after changing this, other part, at the same time, in parts of galaxies, and universe, there is significantly higher presence of gravitation, significantly higher presence of gravitational force, as compared to known matters, and their gravitation. For example, just say this one thing. Like suppose that we are having a galaxy, and let us say this galaxy is having 100 billion stars. Okay? This galaxy is having 100 billion stars. So we can try to calculate that what is the gravity in this part. We can try to assume that what is the gravity acting on a particular substance in a galaxy. We can try to find it out. Okay. We can also try to find the impact of other nearby objects. But when we compare it, we see that in case of any galaxy, the gravitation which we are getting, and when we try to calculate the gravitation from the stars, when we try to calculate the gravitation of the stars, and when we see the actual gravity, it is very different. Like say, let's x is the gravitation. X is the gravitation by the stars. Okay. And the total gravitation is z. This is the total gravitation experienced by any object. Total gravitation experienced by any object in a particular galaxy. So what we see that if we try to compare this, x is only 15% of z. X is only 15% of z. Means within a galaxy, 15% on an average, 15% of the gravity is because of the ordinary matter. Remaining 85% of the gravity within a galaxy is unknown. We don't have a source behind it. That what is responsible for 85% of the gravity within a particular area, within a particular galaxy. So on the basis of this, we have been able to predict that there is some matter which is present here. We are not able to detect it. We are not able to touch it. We are not able to see it, but it is existing. And that particular thing is what we call as dark matter. Okay. So if we compare only the matter part, ordinary matter versus dark matter. So ordinary matter is 15% of all the matter of universe, and dark matter is 85% of all the matter of universe. If you remove the energy part, if you just compare the matter only, so there you will find that 15% of the matter of the universe is ordinary matter, and remaining 85% of the matter is dark matter. So overall, if you compare matter and energy as same, so there you will find ordinary matter plus energy combined together forms 5%. Dark matter forms 27%. But if you just see the matter part only, remove all the energy thing, just see the matter part, there you will find 15% is ordinary matter, remaining 85% is something which we don't know about it, and that we call as dark matter. So we don't know what is dark matter. We don't know it. That's why we call it as dark matter. When we know it, we will rename it. So as of now, there are many such research which are going on across the world, searching for dark matter, trying to find out what is dark matter, what is their property and everything. The LIGO Observatory or the various James Webb Space Telescope, Hubble Telescope. Recently, NASA has launched one in the part of June itself. June, July itself, they have launched, not NASA ISRO, not NISAR part. NASA has launched its own satellite recently in the month of June. They have also been trying to find this dark matter. So there are many such experiments going on in the world just to detect this dark matter. But till now, there is no such achievements. In the last 1 year, there have been at least 5 to 6 articles just about dark matter in newspapers. It is becoming very popular nowadays. It is getting all the limelight. So maybe in the near future, either we will know about it or there will be a question about it. In both ways, you have to prepare. Okay. When we know about it, then also you have to prepare. If there is a question about it, we should be preparing beforehand it. That what is dark matter? What do we know about them? So we will write about dark energy in tomorrow's session. Let me ask the question only. What is gigantic explosion? Means a very loud, very big explosion. No, there is one simple thing. When you see many such news articles which are claiming that we know about the ingredients of dark matter, take this one thing officially. There is no ingredients of dark matter which we know about. There are only projections. There are only such prediction that this may be the ingredients of dark matter. Some of the researchers are claiming from here to there, but in that news you will find they are claiming it. It has not been proved. Draft node, dwarf stars. We will come to that later. Dwarf stars are stars formed from sun-like planets. So we will see them later. Yesterday you say that galaxies travel faster than light. Galaxies are not traveling. Galaxies are getting separated. And yes, Einstein theory of relativity or Einstein's prediction that light is the fastest is not the last theory of physics. It is not the last theory of physics. Before Einstein, many people have said that Earth is flat. So physics is one part which will keep on evolving from time to time. We didn't know about, like Einstein also said that light is a particle. So have we changed that or not? So this will keep on changing. Right now, steady state theory is not that much. Right now, for universe, there is one theory which is accepted worldwide, and that is Big Bang theory. This is the only theory which is accepted globally now because of its many such like experiments which has proved it to be true. Now, of course, everything is found in universe. Universe is not destroying the matter or energy. It is there. Sun is our nearest star, so all those twinkling stars are similar to the sun, but they are very, yes, they are very, very far away from us and not always similar to the sun. They may be much more larger than the sun. Sun is one of the smallest stars. Sun is one of the smallest stars. Not evenly distributed. Dark matter is not evenly distributed. Basically, it is found in certain areas. Yeah. In certain parts of galaxies, it is not evenly distributed. Antimatter is one part we will discuss later. Antimatter, neutrinos, and other thing. It was believed that along with matter, there was creation of antimatter also. We will come to that. Celestial object, what is everything which is in the cosmos is celestial object. Means the objects which are there in the universe, in the space, they are called as celestial object. Like moon is a celestial object, Jupiter is a celestial object, sun is a celestial object. If you see from moon, earth is a celestial object. Is the distance between one galaxy to another galaxy increase? We will come to the galaxy part. See, it is not that if you see this one thing, that is universe moving. Universe is not moving. Universe is expanding. So there is a difference between movement and expansion. Universe is expanding. It is not moving. Like suppose that if you have a balloon and you have taken 2 points on it. Like suppose you have a deflated balloon. You have marked 2 points on it. When you fill that balloon with air, the points will get separated. The points are going to get separated. But it doesn't mean the point is moving. It is the balloon which size is spreading. That's why it will appear to you that they are moving. If universe expanding, then why distance between sun and earth not increase? Sun and, like if we compare the distance between earth and moon, it is also increasing. Moon is going away from us. Okay. There will be a time when you will not have moon. So Chanda Mama ja rahe hai. Okay. So it's not that the stars and planets are constant. And if you see this, moon is going towards the sun. Moon is not like going away from the solar system. Moon is going towards the sun because sun has far more gravitation than earth. Why earth and sun are not going? Okay. They may be shifting, but their shift is so much small that it is negligible. We know many things about black hole. About black hole, we have many such things which we know today. Like we know that there is a particular area in black hole which is called as event horizon. There is a point called as singularity. There is accretion disk also. There is like a ergosphere also. So we know many things about black hole. We don't know what happens beyond black hole, but we know about the black hole, that where they are existing, how they have been created. We know about them. But about the dark matter, we don't know about their creation, their properties, and everything. About black hole, we know that they have enormous density. We can even calculate their gravitation or density also. एलियन लोग यूपीएससी की तैयारी करते हैं, हाँ कल ही आए थे. थंडर पार्ट, सी when we look at this, like suppose here we are having a cloud. When the cloud is getting formed, then we see that the water vapor is rising up, the water droplets are coming down, and there is random movement of these dust particles. So there is going to be a friction in them. They are going to collide with each other. Due to their collision, there is a chance that they will lose some electrons. When they are losing the electrons, a charge is going to develop on them. So let us assume here that by gaining some electrons, this has acquired negative charge. When the cloud has got the negative charge, it is going to induce a polarity, like the comb and the piece of paper. It is also going to induce a polarity over here. So on one side we have the negative charge, here we have the positive charge. If there is rainfall, there is also going to be moisture in the air. Now that wet air or moisture laden air is going to act as a conductor that will facilitate the movement of electrons from the cloud to the plants. And as a result of that, there will be movement of electricity. Now, when we are having movement of the electrons over here, it means electrons are changing their orbit inside the atom. Whenever they are changing their orbits, they are going to release some energy. That energy is released in the form of light. Like for example, if you have a LED bulb, if you switch on the electricity, there is movement of electrons, there is generation of light. In same manner, when the electrons are descending down, when they are coming down, or when they are moving in their orbit, they will release some energy in the form of light. So that is the lightning which we get from the clouds. That lightning is having enormous amount of energy, very high amount of energy. When it is passing through that air, it will heat up the particles of the air, and as a result of that, the particles of the air will start vibrating. When they vibrate, it will create a sound which we see as thunder sound. Now, we cannot store lightning electricity because we don't know where it will stuck. Plus, at the same time, we also don't have that much of storage capacity. We don't have the batteries for storing it. How dark energy is different from normal energy? You can see the light which is coming to you. You can perceive that. You know the property of it. But there are certain energies in which you don't know the property of it. You don't know what is its nature, where it is coming from, where it is getting originated. So that part which we don't know about it, that is simply what we call as dark energy. Yeah. So then let's meet tomorrow and then we will discuss further things.